Hello everybody, I'm Magali Picard and welcome back to the complete educational program video proposed by Demptos Corporate in its Design My Barrel offer. Today, I will talk more about the parameters involved in the spirit stability over the maturation process. During the maturation process, both phenomena occur simultaneously. Spirit penetrates into the wood, which is porous, causing the water and ethanol evaporation, and the oxygen diffuses into the wood from the ambient air surrounding the casks. Oxygen is a fundamental requirement for aging. As observed for wine aging, slow and continuous oxidation of spirit over maturation in oak cask contribute to the quality of the final product. Oxygen permeates the barrel through the pores in the wood and through the joints between the staves. The permeation of oxygen through the wood can be defined as the oxygen transfer rate, namely OTR. The OTR can be influenced by several wood properties, such as its origins, its grain, its thickness, and dryness. Thus, more oxygen enters when the wood is dry, thin, and when the grain is smaller. Some properties of the casks also impact the oxygen transfer. Firstly, the cask size, which refers to the ratio of surface area to volume. Briefly, the smaller the cask, the greater oxygenation. When the cask is small, the extraction of wood components proceeds at a greater rate due to a larger spirit and wood contact. The oxidative reactions are faster and losses by volatilization are greater. Then the reuse of cask. The oxygen transfer decreases over time after they have been filled. This is mainly due to the presence of wood moisture at the surface of the cask. For example, after 10 years of using casks, the transfer of oxygen represents a decrease from 10 to 50%. This drastically slows down the maturation process and limits the chemical reactions responsible to spirit complexity. Tiny amounts of oxygen play a vital role in the spirit aging bouquet, which impacts upon flavor, aroma, and phenolic composition of aged spirits. Actually, oxygen contributes to a large variety of chemical reactions affecting the spirit's sensory profiling. First of all, the oxidation of ethanol, involving successive reactions of acetaldehydes and acetic acid, leading to esterification reactions with increased perception of fruity character in spirit. Then, the oxidation of phenolic aldehydes into phenolic acids. These latter directly react with the various alcohols of the distillate to produce fruity esters. And finally, the oxidation of elagitanins. This reaction forms hydrogen peroxides, which directly react with sulfur compounds, resulting in a decrease of cabbage and asparagus notes. The oxidation of elagitanins also contributes to their polymerization, as well as their association with polysaccharides. This contributes to a decrease of astringency and bitterness sensation and an increase of sweetness perception. Wood elagitanins are easily oxidized and are considered as powerful anti-radical agents. The greater capacity of elagitanins to consume oxygen is due to the presence of several orthohydroxy functions on the periphery of their chemical structure. The presence of elagitanins regulates oxidation mechanism. Instead of oxidizing directly as a harsher and more destructive process, these tannins produce a slowly consumed hydroperoxidizing pool to avoid too brutal radical oxidations. The antioxidant capacity of oak cask is thus influenced by several parameters involved in the barrel making process. The oxidation, in relation to the oxygen transfer rate, Quercus robur from European species has the higher antioxidant capacity, and Quercus alba the lower. This is due to differences in the total polyphenolic composition of the oak samples. Strong correlations are thus observed between antioxidant capacity and several phenolic acids such as gallic, elagic, vanillic, and picomaric acids, as well as elagitannins such as roberins A and E, granidine, vescalagine, and castalagine concentrations. Then the toasting step. Non-toasted oak wood samples showed more antioxidant power than those toasted. This decrease of the antioxidant activity observed with the toasting process is directly linked to the degradation of the wood polyphenolic compounds. In spirit products, the burning sensation associated with pure alcohols leads to an excessive skin stimulant and thus the formation of reactive oxygen species. Ethanol, which is the main component of spirit, is perceived by stimulating the sweetness and bitterness taste per receptor cells. It also acts on the epidermal stimulus, which can provide in excess a too strong burning sensation due to the formation of reactive oxygen species. During maturation, the abundance of two elagitannins, elagic and gallic acids, and the lineal lioresinol increases. These compounds possess a reactive oxygen scavenging activity. They are capable of reacting with reactive oxygen species or other reactive free radicals. Through this oxygen scavenging activity, these three compounds prevent the formation of reactive oxygen species and provide a comfortable aftertaste by reducing the alcoholic burning sensation in matured spirit. When talking about spirit, there is one phenomenon that affects every single batch of spirit made. This is the angel chair. Due to the porosity of the cask, some of the spirit inside evaporate in the open air during maturation process. Although it reduces an almost undrinkable and high-proof spirit into a soft and more palatable one, the total volume of spirit in cask can drop quite significantly, about 2% per year. The angel chair phenomena has been found to vary with the environmental conditions in the warehouse. Depending on where the spirit produced, the angel chair will have a different effect on it. Humidity and temperature of the warehouse are the two main parameters conditioning the speed of the water and alcohol evaporation of the spirit. Raising temperature increases the evaporation losses of both ethanol and water. In the same time, in low humidity climates, more water will evaporate than alcohol, increasing the overall spirit strength, while high humidity climates, like in Scotland for example, more ethanol than water is lost and strength decreases. For equivalent casks maturing the same spirit in a same climatic environment, the alcoholic strength can increase from the bottom to the top tier of the warehouse. It is known that the casks on top tier are marked by a daily decrease in humidity as the temperature increases, leading to a higher water loss. Conversely, the casks of the bottom tier are most stable with a relative high humidity. Evaporation may then result in further effects due to the changes in the proof of the maturing distillate. Depending on the spirit strength, the extraction process of compounds from the wood to the liquid is directly impacted. For example, a better extraction of whiskey lactans responsible to coconut flavor is reached at 40% of alcohol content. Optimal extraction of tannins is reached at 55%, and up to 70%, the rate of extraction of the major parts of wood compounds tends to decrease. These variations are due to the both influence of the hydrolytic reactions, such as the breakdown of polymeric materials, and the solubility of degraded compounds improved with increasing alcohol concentration. The highest rate of extraction will occur at the concentration when the two processes are optimally balanced. So thanks everyone for watching this last training video. You can find all the most important key points in the reference handbook. And finally, I hope this educational program gives you new information about the relationship between the wood and spirit over maturation, and how we can explain the development of the qualitative spirit aging bouquet from a scientific point of view. Bye!